All right, so you're getting tired. Are you getting tired of using this chart? Because we're going to use it again. In this chart, the first column is H and the middle column is G. So this time we're doing it for G. So hopefully you're seeing the consistency to this. I'm going to get to my C's, and again, I'm looking for the middle column. Where are they? There we go. So here's my CO right there. And the middle column says that my CO is negative 137.15. I'm going to get to my CO2 right there. And this column says this value is negative 394.36. I'm going to jump over to my iron. So that's my I's, HI, my iron value. And look, it's 0. So let me pop up for just a second. When is HF 0? Well, it looks as though maybe the elements are 0 for this one. And maybe we'll scroll again and we'll try to find something. Here's iodine right there. So iodine's 0 there. And maybe we'll look for H2. That one is also 0 as a gas. So yes, this is one of those where the elements in their standard state are 0. So we've read the chart. Let's double check our units at the very top. Well, let me get my other iron value in here. So my iron, Fe2O3, that's the middle number, is negative 742.2. I also just noticed I didn't put my numbers in. This is 1 times that number. This is 3 times that number. This is 2 times that number. And this is 3 times that number. So the units on the G value, we're going to go to the top and just make sure we got them. Look, it's kilojoules per mole. Notice it's got that little circle, so that's standard state, so that's 25 degrees Celsius and 1 ATM. All right, so now I'm going to just put it in the equation. So delta G is equal to, so I got these guys, copy, paste. Remember that it's them added, minus these guys on the right, or the left, I'm sorry. They're going to be on the right. Paste. And I'm going to take out my little one here. Notice that that 0, we're going to add these terms together. But that negative gets distributed to him and to him. So I'm about to be at I'm going to take, it's a negative, so that becomes a positive. And then this term right here becomes a negative. So I'm going to put this all in my calculator. I'm not going to worry about the 2 times the 0 because that's just 0. So 3 times, I did it twice, clear. 3 times negative 394.36 plus 742.2 minus 3 times negative 137.15. So I got for this value that my delta G is equal to negative 29.412 kilojoules per mole. So that's one way to calculate your delta G value. But it only gives you the delta G when you're at this temperature and pressure. What if you want to do it at another temperature? That's one reason why our G delta H equation is so very helpful. We can do this same equation, but what we need to do is grab our G value, our H value, and our S value from all of our reactions that we calculated. So the G value right here is, actually wait just a second, I'm going to pause on the G value because that's actually what I'm going to calculate. The H value was higher up. Let me zoom up to the H value. There's our S value, 15.5. So I'll go back here. This value was 15.5 kilojoules. That was S, sorry. Joules. 15.5 joules per mole Kelvin. So that's my S value. My H value, I think that was quite a bit higher. It's right here. Negative 24.77. So negative 24.77. And then this value was kilojoules per mole. Now I got to scooch these over just a little bit, maybe a little more, to get my T term in. So we're going to check this at 25, but then I'll show you can use it for other values too. So negative, and then the T value at 25, that's 298.15 Kelvin. And this is the equation that we're using. And so we're going to say negative 24.77 minus parentheses 298.15, parentheses closed, times parentheses 15.5. And that gives me, oops, let me show you. Here's the big kicker. You can't just put this in as the kilojoule value because it isn't. It's a joule. So what we also have to do is we have to then do in 1 times 10 to the third joules, we have 1 kilojoule. So let me go back to the equation and use that value. So negative 24.77 minus 298.15 times parentheses 15.5 times, I'm actually just going to say divided by 1,000. So I have to use my E key. Divided by 1, 2, 3. And my term should come out to be 29 point. It depends on how many sig figs you want to carry it over with. We're going to say 3 at this point. And that is my value in kilojoules per mole. And let's see how close we were. And I left off my negative here. Look right there. So you can calculate delta G using the delta G values on the chart. Delta H of formation. You can calculate G of reaction using G of formation values. You can also use this equation and you can calculate delta G values from delta H of reaction values that came from the delta HF values and the SF values. Now, on a question on like homework and stuff, this will be given to you. You don't have to calculate both of these separately using the products minus reactants. That's going to be given to you. However, the advantage to this equation is that it's not just at one temperature. So if I wanted to know, well, what happens if I move this on up to 300 Kelvin, or let's say 400 Kelvin, or what if I changed it down? Well, let's see. If I change this value right here, let me put it up by 100 right there. Now, all I have to do is just change that same equation and make that 3. And now I know at this new temperature, my delta G value is negative 30.94. Remember, this one over here was negative 29.4. So it's gone up a little bit. So delta G values will change with temperature as it moves along. So that's especially the big advantage to this equation.